Hi, this is Verna from Drayton Valley Libraries. I'm coming to you from Check Your Cupboard Science, which we just had today. As you can see from my desk, we had a busy time. So what we were doing today was exploring the colors of light. So let's see if I can show you what we started out with and say thank you to Steve Spangler website for this idea. So we started out with a disappearing color wheel, which basically you're going to cut a circle out of some cardboard. You're going to cut the same size circle out of some paper. And then you're going to color your wheel. Now mine has 6 colors on it. It's in 6. I'm pretty sure it works just as well if you do different amounts of color or whatever, but color the whole thing. And then you're going to glue it to the cardboard. Okay, so we got cardboard, and then on the other side we've got our color. Then you're going to poke 2 holes through it. Take a string. I did a string that was about as long as my arm stretched out, and run the string one end through each hole and then tie it up at the other end. So once you get this put together, you're going to spin it around like a skipping rope. Okay, get it all spun up. And then when you are ready, you're going to stretch it tight. That one didn't work quite as good. Let me try the one that I made today. But what you're going to try and do is to look at the part that has all the color on it, specifically when you stretch it really tight. Okay, let's see if this one will work for us. You ready? Now you might have noticed couldn't really see the colors at first. So I'm going to count it down. 3, 2, 1. Where's the color? So this is called the disappearing color wheel. What's happening is those colors are spinning around so fast that our eyes cannot discern the difference between the different colors. They just all blend together. And when all the colors blend together with light, you end up with white. So it kind of goes in that direction. So there's a few interesting things that we learned today. One was that traditionally we understand the primary colors to be red, yellow, and blue, but actually when we're taking tangible, touchable things like paint or markers and mixing them together, the primary colors are actually yellow, magenta, and cyan. So if anybody's ever worked in an office and they're looking at why is the printer ink come in yellow, magenta, and cyan, that's why we just use red and blue when we're teaching younger children, because they know those colors and they don't know magenta and cyan. Anyways, so that was interesting to learn, but then also when we deal with light, there's different primary colors for that as well. So the primary colors for light are on my flashlights. This was our second activity that we did today. They are red, green, and blue. So if you've ever done any work on computers and having to make a new color to ask for an RGB value, they're asking for the red, green, blue light value of the color you're trying to create, because screens are emitting light and that's how they create the color that we see. So what we did anyways was take a regular flashlight, or you can use a phone if it has a flashlight app on it as well, and cover up the light part with just some clear tape. Then you're going to take markers that match these primary colors of light. Ooh, match them up with the screen there maybe, I don't know. There we go, you take the markers and you're going to color over that tape so that you're not wrecking your flashlight, but you can create, and will it do it for us? A red glow. Oh, this flashlight's a special one, it does many things. Okay, or it creates a green glow, or it creates a blue glow. Okay. Then what we did with those is we took a white backdrop so that we could see what was happening, and we took a toy and we just, first of all, shone a regular flashlight on it to make a shadow. When we shine a regular flashlight, the kind of shadow you're going to see is black, because we learned that when we have all the colors of light combined together, they create white. So if you've ever experienced seeing the sun shine through a glass or some crystal or something like that, and it creates rainbows, that white light from the sun is being broken up into its many different wavelengths. Actually, each color of light has a different wavelength. So when we combine all those together, it gets white. We talked about the fact that when you take tangible things as well, if you combine all those colors, say you take paint and you combine them all, it ideally should make black. It usually makes brown, but a mixture of all colors tangible is black. A mixture of all light colors is white. And then reverse it, if you have no tangible colors, no paint, you essentially have white, nothing. Sorry, yeah, if you have white, but if you have no colors of light, you have black, absence of light, right? So shining a regular white light on something would give you the shadow that is just black. But if you make these flashlights, give it a try, shine the light on your object. You should have something white behind it there. And I'm not gonna do it for you on the video because we found it doesn't work very well through the screens, but try it yourself at home. Shine the red light on it and see what color of a shadow you have. Shine your green, shine your blue. And I will share a link or two that are kind of going to help you with this. So we thank Steve Spangler for the color wheel idea. This light idea I found on a YouTube channel called The Dad Lab, which was pretty cool. And when you watch it, you might not get results just like he got right away, but play around with your angles of your light, how close and how far they are, and you might get something close to what he has. It's really beautiful what he's got there. And I may also send you a link to show you a color wheel that is a little more true to life than our traditional primary colors that we think of. And when you notice the shadows and what color of shadows are being created, whether it's in the video from the Dad Lab or it's in your own experimentation, you'll kind of see what's going on when you block the red light, which color shows. When the red light is blocked by your toy, which color shows. When the blue light is blocked by your toy, which color shows in the shadow. Anyways, have fun with that. And if you want to join us for some more science, you will find us next Tuesday, 3 o'clock on Zoom. If you want to actually join in, you need to contact the library, get your Zoom privileges set up. But you can also view a summary video later in the day if you happen to miss that. All right, we'll see you later. I'm a mad scientist.